Oh, hey everybody. Sorry, ignore my potato dog's snoring, but she's insisting on being on my lap. But so I've been having a lot of trouble uploading our full class lessons to YouTube, to Google Classroom, anything like that, because it's taking a super long time. And I thought it might be easier if I just do a quick review of the notes for this week. So I'm going to start with the notes from Tuesday, and then I'll do the notes from Friday. Feel free to skip around if you only miss one of those lessons, but I figured this might be quicker and easier. So I'm going to put this sack of potatoes down and then flip over to my doc cam. So 1 second. Ooh, not a great start, but we are going to start by going over the notes from August 25th on factorization. So if this was in your actual notebook, it's very likely that you would already have a do now here. I'm not going over the do now because I wanted to save some time, save some space. And you can always go back and look at the do now from the slideshow that I upload. You can do that on your own time if you missed. So what we were talking about is factorization. Factorization, you need to know what factor means. So that's the first word. A factor is any number, and right now we're talking about positive integers, that divides evenly into a bigger number. So a couple examples. Example 1 is 6. We'll do example 2 in a minute. So really all it's asking is what times what is going to equal 6. This is a pretty easy one. 1 times 6 equals 6, and 2 times 3 equals 6. So that's all we've got to do. Our factors of 6 are 1, 6, 2, and 3. I don't care what order you write them in, as long as you write them all down. An example that might be a little bit more tricky would be something like 48, and this is where that division comes in. So looking at 48, I already know 1 times 48 gives me 48. What about 2? I think 2 is going to work, yeah. But if I'm not sure and I really want to check my work, all I have to do would be open up my calculator. 48 divided by 2 is 24. That is a whole number, so it's going to work. 2 times 24 is 48. I'm going to keep going. Let me try 3. 48 divided by 3, that works. That's a whole number. 3 times 16 is 48. And I'm going to keep going. 48 divided by 4. That works. 4 times 12 is 48. Let's try 5. 48 divided by 5. Ooh, that does not work. 9.6 is not a whole number, so it does not divide evenly. 5 is not a factor. What about 6? Perfect. 6 times 8. That does work. Let me try 7. No, 7 does not work. That is definitely not a whole number. And 8. All right, 8 works. But we've actually already got 6 and 8 down. So we're done. We've got all of our factors. So our factors of 48, and I'm going to write this by writing 48 and then 2 dots, are going to be 1, 48, 2, 24, 3, 16, 4, 12, 6, and 8. And I wrote those out of order. That's okay. I don't care. As long as I can see that you get all of these factors down, you're good to go. So where this really comes in handy is when we're talking about prime factorization. Prime factorization is breaking down numbers into only prime numbers. And as a really super duper quick review, a prime number is a number that the only factors are going to be 1 and itself. So for example, 6 had 4 different factors, 1, 6, 2, and 3. But if I put a 5 here, the only numbers would be 1 and 5 that are factors. Any number that only has 1 and itself as factors, so like 7 times 1 or 11 times 1 are the only factors, is a prime number. So what we're doing now is we're going to do the same sort of thing and find factors, but we're taking out only prime numbers. And so here's an example if we did 24. I would start by taking out a 2. That is my smallest prime number that goes into 24. 2 times 12 is 24. 2 is a prime number, so it's kind of frozen right there. And I'm going to keep going. 2 times 6 would give me 12. 2 is a prime number, it's frozen right now. And 2 times 3 would give me 6. 2 and 3, those are both prime numbers. So now I've got all my prime numbers. The way I'm going to write this answer is going to be 2 times 2 times 2 times 3 equals 24. And if you're like remembering this from last year, it's really starting to become familiar. You might remember that we can write this in a different form. We would notice that there are 3 2's, 1, 2, 3. And the way we could write that would be 2 cubed times 3 is 24. For right now, I'm actually going to stick to this longer version. And that's because I think it helps a lot when we come to greatest common factor. But I would accept either answer 1 or answer 2. Both of those are correct. Awful box. That's pretty much all you need to do. So now we're going to move on to one more example that's a little bit tricky. And that is 27x cubed. We're going to do the prime factorization of that number. All right, so our very last example, how I'm going to split this up is going to be, I'm not sure. When I look at this at first, I kind of get a little bit overwhelmed. That's a lot going on there. A number, a variable, an exponent. I don't really know where to start. So I'm going to make this easy on myself, and I'm going to split it up. Because if we remember, this is 27 times x cubed. It could also be written like this, 27 times x cubed, which means that I can split those parts up. So I'm going to take 27 over here and x cubed over here. And I'll put them back together at the end. But for right now, I'm kind of just going to pretend like that x cubed, it doesn't even exist. Don't care about it. I might have to move this actually. Okay. All right, there. So I'm going to take this 27 and start factoring. A prime number that goes into 27, 3. And if you're not sure, just divide 27 by 2. That would not work. But 27 will divide by 3 because 3 times 9 is 27. And then 9, we're going to keep going. Ooh, that's an easy one. 3 times 3. Now I have all my prime numbers. And I'm going to kind of pause. So I'm going to write it out in a minute. But first, I'm going to go and look at this x cubed. And I really think that these are easier. They look a little complicated, but all you have to remember is what this exponent is telling you is that this is x times x times x. You just have our x times x 3 times. X times x times x. That's it. That's all you got to do. So now that I've got my 2 different parts, I can bring them back together. So I am going to draw my box first, and it didn't make it any nicer still. Geez. And I'm going to write this the long way, and I'm going to go 3 times 3 times 3, 1, 2, 3, times x times x times x. And of course, drawing my box first was not a good idea. It's kind of like pouring in your milk before the cereal. It's just silly. Because I don't have room to write equals 27x cubed. All right, so that was the total review of the notes from August 25th, which was Tuesday. We covered factors, factorization, and prime factorization. So I'm going to pause the video. This is a time where if you only missed Tuesday, you're good to log off. But if you missed Friday as well, I'm going to keep going with that, but I'm going to pause and get a new piece of paper. All right, so now we're going to move on to the notes from August 28th, which was the Friday class. Topic is 1.3 greatest common factor. And I did tell everyone, don't get confused by this numbering scale. 1.3 just means unit 1, day 3. So like, don't get confused. If you just write greatest common factor, that's all right too. So when finding greatest common factor, there are 3 steps. And I'm going to go over these steps first. Then we're going to do some easier examples, then some more challenging ones. So your steps to finding greatest common factor. Step 1, find all of the prime factors of both numbers. So you're going to start with 2 numbers today, and you're going to find all the prime factorization, all the prime factors for both those numbers. Step 2 is you're going to identify the common prime factors. I put this in a box because I like to circle my prime factors. That's how I identify them. Common means the same. So you're going to have 2 numbers. You're going to find all their prime factors, and then you're going to figure out which ones are the same. Once you have those common prime factors, you multiply them. This is really, really useful for when we move into more advanced factoring. What we're trying to do is break down different numbers, figure out what's similar about them, and take that out so that we can better prepare ourselves to factor big polynomials later on. There's one more quick note. If there are no common factors, the greatest common factor is 1. And that's just because every single number, at least it's going to have 1 times itself as a factor. So if I gave you 7 and 8, the greatest common factor they have is 1. They don't have any other factors that are the same, but we're going to move into a couple examples that should make that a little bit more clear. All right, so example 1, you are given 2 numbers, 4 and 10. This part is actually just asking you to list all the factors of each, then identify the greatest common factor. So right now I'm doing what I did yesterday with factoring. I'm just going to find the factors. So 1 times 4 equals 4. 2 times 2 equals 4. So my factors of 4 are 1, 2, and 4. I'm going to do the same thing with 10. 1 times 10 is 10. 2 times 5 is 10. So my factors of 10, I'm going to write these or underline them in a different color, are 1, 10, 2, and 5. And so I'm going to write my 10 with my 2 dots. 1, 2, 5, and 10. What I'm going to do now is I have my factors of 4 and my factors of 10. You're going to look and see what is the biggest one that they have in common. It's going to be 2. They both have a 2 right here. 2 is their greatest common factor. We're going to do this once more with the numbers 30 and 16. 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. And those ones I know off the top of my head, but I think there are a couple missing still. So I'm going to try 4. 30 divided by 4. My calculator. Doesn't work. 30 divided by 5. That does work. 5 times 6 will give me 30. Now I have all my factors of 30. 1, 30. 2, 15. 3, 10. 5, 6. And I'm going to put a little box around these just so we can see them. And I'm going to do the same thing with 16. 1 times 16. 2 times 8. We got to think, does anything times 3 equal 16? No. What about 4? Yeah, 4 times 4 is 16. So my factors of 16 are 1, 2, 4, 8, 16. And those ones I wrote in order, it doesn't matter. Now what I have to do though is look at these two numbers, all these factors here and all these factors here, and identify which is the greatest that they have in common. Let's see. There's no 30 over here. There's no 15. No 16 over here. We're just trying to compare them. You can write these on top of each other too. Sometimes that's easier. I just didn't have a lot of space on this page. No 8, no 10. I'm trying to see which ones match. Which number is in both of these lists. I'm not seeing a 6 over here. I'm not seeing a 4 over here. Not seeing a 5. No 3. So I guess the greatest common factor is going to be 2. So those were two examples just to kind of show you what we're going to be doing, trying to explain what we're trying to find. But if you were given a really big number, this would be such a pain to write all these out and start to cross them out and figure it out. So we're going to use prime factorization to make this whole process a lot easier. So if I'm just going to really quickly pull out a piece of paper to block the top part so we don't get confused. Now we're going to start using our steps 1 through 3 that we wrote down at the beginning of our notes to find the greatest common factors of these sets of numbers. So we're going to start with 40 and 48. Step 1 was to find the prime factorization of each number. And if you need to review this, you can go rewind this video and look at yesterday's notes. I'm not going to spend too much time reviewing these right now. So 40, I'm going to take out a 2, that's a prime number. 2 times 20. I'm going to keep going. 2 times 10 is 20. And 2 and 5. I have now got all my numbers to be prime. So 40 is 2 times 2 times 2 times 5. I'm going to pause and I'm going to do the same thing with 48. So I'm going to take out a 2 because 2 times 24 is going to give me 48. Take out another 2 because 2 times 12 gives me 24. And I'm going to keep going. 2 times 6 gives me 12. And 2 times 3 gives me 6. Now I have all of the prime numbers that I could ever want. And I'm going to write 48 right over here, because I like when they're lined up on top of each other. 4 2s, 2, times 2 times 2 times 2, and 1 3 times 3. So now what I'm going to do for step 2 is find my common factors. So we've got 2 2's here, got some 2's here, more 2's, but 48 has an extra 2 that 40 does not, so that one does not count. There's no 5 in 48, and 3 is not a factor of 40. So I have my common factors of 2, 2, and 2. My final step is step 3, which is to multiply my common factors. So all I have to do, 2 times 2 times 2 equals 8. That means my greatest common factor is 8. And so the reason that this is actually easier is because I would have had to write out all of the factors of 48 and all the factors of 40 in order to get to 8. This is a lot easier, especially as our numbers get bigger and more complicated. Now I'm going to move on to this next example. Again, if you need a refresher on how to factor these numbers or do prime factorization, please watch the video over the first half of the video. But what I recommend is starting with just one at a time. And then even further, I'm going to split these up. So I have 10 m cubed and n. I'm going to move right into my prime factorization of 10. I know how to do this. 2 times 5, and that's it. Now I'm going to pause and look at just m cubed. I don't need the sticky note anymore, we got this. If we recall, all we have to do for this is m times m times m. 3 different m's, that's it. And then finally, my n, there's just one n. I just leave it. So the prime factorization of 10m cubed n equals 2 times 5 times m times m times m times n. Now I'm going to focus on this other number, 20 m and n. Looking at my 20 first, I take out a 2 and a 10. Keep going. I have a 2 and a 5. I don't even need to do anything with this m and n because there's only one of them. So those can stay. And my prime factorization of 20 mn is 2 times 2 times 5 times m times n. And now we just have to identify what they have in common. So we did step 1, factorization. Step 2, find our common factors. Easy enough. All right, these line up. We got some 2's. Ooh. 10m cubed n does not have 2 2's, so that one doesn't count. But they both have a 5. They both have 1m. 20mn does not have these extra m's. And they both have an n. So for this one, now I'm going to write it all out. Step 3, my greatest common factor is going to be 2 times 5 times m times n. And you could either leave it in this expanded version, or you could write your answer as 2 times 5 is 10 m n. I'm going to leave it as 10 mn because it's simpler, but either of those would be correct. Now I know there's a lot going on here, so you do have some extra practice problems in your Google Classroom of these, and I did give you the answers. I did not show you how to do the work. So if you have any questions, please feel free to text or email me, and I will send you a screenshot of the work. You just have to ask for it. All right, and that is all for the notes for week 1. Have a great weekend.